Okay, let's take a look at combining like terms. X plus x equals 2x. How do we know if that's true? Well, make up a random value for x. X equals 5 star. Put it into the question. 5 plus 5, excuse me, I forgot to circle my answer above, equals 2 times 5. And on the left, we have 5 plus 5 is 10. And on the right, we have 2 times 5 is 10. Therefore, we know our answer was correct. In the notes, 3y plus 2y equals 5y. Just add or subtract the coefficients. X squared plus x squared is 1x squared plus 1x squared. It's a like term. X squared is my like term. I'm going to put it there. That's a 2. And I'm simply going to add my coefficients. Notice I wrote my like terms first, then thought about what the coefficients were. 1 plus 1 is 2. Circle our answer. Pick it if you wanted to. Pick a number if you wanted to. Put it in, whichever. Okay, so adding and subtracting the coefficients. Next example in the notes. Negative 9xy plus 7xy. Well, the coefficient, the term is xy. So we just add or subtract the coefficients. Negative 9 plus 7 is negative 2. So it's just negative 2xy. I've circled the answer. Okay, combining like terms. So 2 plus x plus 3. Well, the like terms are 3 and 2. In the notes, I've rearranged the order of the terms. X plus 2 plus 3. Do that if you want to, but it's a lot of work. So 2 plus 3 is 5. X plus 5. Circle our answer, combining like terms. So 3x plus 1 minus x equals, well, I could rearrange the order of the terms, so let's not this time. I'm going to circle my like terms. Positive 3x and negative 1x. Put a 1 in front of the x if you like. 3x minus 1x is 2x. And then we still have a plus 1 that we haven't touched. Circle our answer. So as you can see in the notes, sometimes off to the right, I actually write the actual step that I did. 3x minus 1x equals 2x. And 3 minus 1 is 2, so I just subtract the coefficients, and that's what we get. Okay, so 3 plus x squared plus 2x minus 1 plus 3x squared plus x. Well, we could rearrange the order of the terms in the notes, or just circle the like terms. Positive x squared, positive 3x squared. Box the numbers. Positive 3, negative 1. Cloud the x's all by themselves. Let's do the highest degree first. So circles. Positive x squared plus 3x squared is 1x squared. Excuse me, plus 3x squared. So that's going to be 4x squared. I'm going to cross off what I did. Now the clouds. Positive 2x plus x is plus 3x. Then I just have a 3 minus 1, which is positive 2. Circle our answer. So again, off to the right, I've got all those notes. Rearrange the order of the terms if you want to. Then combine the like terms. In the box, we've got each one of those individual calculations. Then a reminder, put it from highest degree to lowest degree. In the last section, we learned about highest degree. The highest degree is 2, then 1, then technically 2x to the 0, etc. Okay, combining like terms. 5 minus x plus 2. So we have a positive 5 and a positive 2. And 5 plus 2 is 7 minus x. And then rearrange the order. Oh, I didn't in the notes. Haha. Half mark I lost. rearrange it. Notice the negative is part of the x, so it stays with the x. So 2x minus 3 plus 3x. Let's circle the like terms. We have 2x and positive 3x. Don't forget to circle the sign. 2x plus 3x is 5x minus 3. Circle our answer. Oh, I forgot a couple off to the right. Negative 2x plus 3 minus x. Well, I have negative 2x and negative 1x, give it a 1. And negative 2 minus 1, adding and subtracting on the number line is negative 3. Negative 3x. Then we have a positive 3. Continuing. Negative 3 minus 2x plus 1 plus 6x. This time we have two like terms. So let's circle the numbers, negative 3 and positive 1. And let's box the x's. And negative 3 plus 1 is negative 2. And negative 2 plus 6 is 4 plus 4x. And rearrange the order of the terms. Put the positive in front if that makes you feel better. And remember, the sign stays. The sign stays with the number or letter. Shrink that stuff up a bit. Okay, x squared minus 2 minus 2x, excuse me, plus 3. And what does that equal? Excuse me? That will happen from time to time. My fault. I will pause once a chapter. My fault. I partially copy down some of whichever. I need to erase it back to x squared. I'll give you a second to do that if you were doing that. I need to point to where I look, one of my boot camps. Plus 3x minus 2x squared minus 1 minus 2x. I print it, but it's bad for the environment. Okay, so we have x squared and negative 2x squared as circles. Let's box parallelogram and box the x terms. Ooh, forgot the sign. Don't be lazy. Erase it and properly correct it. Maybe do it in red to remind you that you forgot that. Then we have one term that's just all by itself. So let's give it a cloud. And then let's start with the highest degree. So we have 1x squared, so we can put a 1 in front. And we can do 1x squared minus 2x squared, which is going to be negative 1x squared, or as you can see in the notes, just negative x squared. Then we have positive 3x minus 2x, which is 1x or positive x, 1x, whatever. And then we just have a minus 1 all by itself if it had another number to combine it with, obviously. So circle, square, cloud, triangle, whatever the like terms. If necessary, write the calculation off to the right all by itself as you can see carefully through the notes. What I forgot to do in the last step is cross off the things as I did them. A good idea, as you can see in the notes. English sentences, remember to cross off the terms you have dealt with, what I just forgot. Couple things down at the bottom in the box. 5xy plus 2yx. Well, xy is the same as yx, as you can see in the box. They're the same. So you can add them. Off to the right, x squared y cubed is equal to y cubed x squared. If a times b is the same as b times a, then this is allowed. So if you see a term that's funny, then either rearrange the order in alphabetical or something, and then add or subtract them if it's allowed. Remember, we're just adding or subtracting the coefficients if they are like terms and carrying everything else down. So we've taken a look at the definitions. We've taken a look at adding and subtracting. Now we're going to multiply and divide.